Welcome to lesson 6, where we will be talking about the surface area of right prisms. Starting off with some vocabulary, what surface area is. And surface area is the total area of the surface of a 3D object. So this box of Toblerone, the surface area is the actual packaging. It's the amount of cardboard that it takes to make the whole package. A lateral face are the faces in a prism or a pyramid that are not the bases. So in this rectangular prism we have right here, there's our base, there's our base. So our lateral faces are everything else. Or if you unfold it, it's like the sides where all the printing would be, or the logos or whatever, if this were an advertisement. The lateral faces of this Toblerone, again, that's a lateral face, and then if you could see the other sides, it'd be everything but the base. And we need to know what the lateral faces are because sometimes we only need to know what our lateral surface area is, which is the sum of the area of our lateral faces. So again, if I was just looking for lateral surface area, I would just be looking for those parts. Everything but the base. What is the area of everything but our two bases? And then lastly, we'll be looking at nets. And nets are patterns that you can cut and fold to make a model of a solid shape. So right here we have the net of a cube. So here is our cube. And then the net is as if I cut it open and showed what shape it would look like. So my net for this Toblerone might look something like this. Or there's our two bases. And then everything else is those lateral faces or that lateral surface area. I'll just highlight that blue. There's the lateral surface area. And all this comes in handy when we start approaching finding surface area of more complicated figures. So here we have a prism. And one way you can approach this is by calculating the area of each lateral face and each base, and then just adding it all together. So there's one lateral face, and two lateral face, three lateral face, four lateral face, and so on and so on. There would be a fifth one there, 6 1, 7 1, 8 1, 9 1, 10 1, 11 1, 12. So it'd be 12 lateral faces that we would end up calculating. And then also our bases. There's one base, and then there would be another base down in here. Okay, this, if you have a figure like this method is really, really annoying because we would basically be doing the same thing 12 times, where we would be taking the area of one of our lateral faces, which is a long rectangle that is 2 inches by 11 inches, and saying that we have 12 things that are 22 inches long, and then our base. That's a horrible drawing, not to scale, but whatever, where all of these are 2. So we could cut that up into a series of squares. Again, that was a terrible drawing. Let me fix this real quick. Much better. Okay, so there's area of 4, there's area of 4, area of 4, area of 4, area of 4. So total area is 4 times 1, 2, 3, 4, 5. 20 inches squared. There we go. So we would have to then add 11 more of these. So in this case, this approach isn't the best thing. Let's move on to our second approach, which would be great for this particular prism. So our second approach would be to identify the faces that are identical and calculate the area of one, then multiply. So that's what I'm going to do here. Let me redraw those faces. First, we'll identify we have 12 identical lateral faces, and then we're going to have 2 bases. Okay. So we've already established that each of those lateral faces are 22 inches squared. So we could say that our lateral surface area is equal to 22 times 12, or that lateral surface area is 264 square inches. And now let's do the bases. So we already established that the base has an area of 20 inches squared, and so there are two of them. So our surface area of our bases is 40 inches squared, and so then you would combine those two surface areas. So the total surface area then is 304 square inches. All right, let's do one last method. And this approach uses more of a net. So we could unfold this prism into a net and then use one large rectangle instead of 12 smaller ones. So the net of this figure would look something like this. So what we have here are two bases in red and then our lateral surface area in blue. And what is helpful about doing a net like this is we already know our height is 11. And then this length of our figure right here is the perimeter of our base. So you can do a really quick calculation here and say, well, the perimeter of my base is 2 plus 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 2, or 2 times 12. So perimeter of base, in this case, is 2 times 12, which is 24 inches. So we know that the perimeter of our base is 24 inches. So we can very quickly find the lateral surface area by saying that it is the perimeter of our base times the height of our figure. So in this case, it gets us very quickly to that 264 square inches that we were looking for. So this is still 264 inches squared. And then you can just add on those bases, which we already know. So I'm not going to redo it all, but I do like this method a lot, because once you find the perimeter of that base, you're really solid. All right, you go ahead and try it using either adding the areas of all of your faces or using the perimeter of the base. When you come back to check, I will be using the perimeter of the base, but you can always just check and make sure that your answer is correct. So the perimeter of our base is 22 centimeters. And again, I got that by taking all of the dimensions of that base and just adding them together, which means that the lateral surface area is 176 square centimeters. Next, we'll find the area of the base. So the area of both bases together is 58 cm squared. So then our total surface area is 234 square centimeters. All right, good luck with your journal problems. Let me know how I can help you all. Thank you.